exact queries. For example, we have XQuery, which is the language recommended by the World Wide Web Consortium. And as example of an exact queries, let's say we want to select email addresses and skills of people who have a Java skill level above 3 and have more than years of experience. This is how the request is written in XQueries. As the SQL language, XQueries consist of the list of clauses. For example, we have the clauses for, where, let, order, by, returned. The problem with this kind of query is that only a result that satisfies all the conditions must be returned. But due to the non-existence or lack of knowledge of the model of the document being queried, documents are queried almost blindly. And the resulting problem is that such requests will generally return no result. This is the case of two specific queries having no match with the structure or the values of the document in questions, or a large number of results. This is the case of two var queries intensively using wildcards. So a request with preferences aims to be a solution to this problem. This kind of request will consist on two parts. The first part defines mandatory requirements, also called constraints. And the second part, optional requirements, called reaches or preferences. For example, a user may want to retrieve all elements A having properties B and C, but will prefer elements A having in addition properties D and E. The result to this kind of request must necessarily satisfy the first and the second part of the request. However, if there exists at least one answer satisfying both parts, only those answers must be returned to the user. Based on these definitions of the request with preferences, we propose the language XQuery preference that allows to express preferences on the values and the structure of the document. Concerning preferences on the structure, we use this new operator, an unary operator applicable to an element in part expressions. For example, we have in these part expressions, elements A and C are mandatory, and element B is preference. So a path containing element B will be more relevant. Regarding preferences on the values, we introduce a new clause pref, similar to the clause where, but the only difference is that conditions specified in the clause pref are optional, but the satisfaction of those conditions will improve the relevance of the corresponding answers. We define the grammar for the language XQuery preference based on a significant subset of XQuery. Here we have the new clause pref, and phi is a Boolean formula defining preferences on the values. And expart expressions are extended with the new operator. So based on this grammar, we can now write and express requests with preferences. Let's consider a query in which the user is looking for a candidate with Java skills and at least a diploma level above 3. But we like this candidate to have at least 2 years of experiences and skills with the framework Spring Boot. Here, the conditions on Java skills and diploma levels are mandatory, and the conditions on the number of years of experience and skills with the framework Spring Boot are preference. Also, the condition regarding the profile of the user is a preference on the structure. So this is how the request is written using the XQuery preference language, the pref condition for preference of the value, and our new operator for preference on the structure. So generally, to be represented, to be evaluated, XQuery request must be represented in a model. In the literature, we have the generalized tree pattern model, also called a GTP, that helps to represent XQuery request. The model consists on a tree and a formula. The nodes of the tree are labeled with different variables, and edges define structural relationship between elements in the query. So for example, for these part expressions, this is how it is represented in the tree of the model. And the Boolean formula defined a combination of predicates applicable to the nodes of the tree. And the formula gives the information about the tag, the content, or other properties. So we extend this model by integrating elements for representation of preferences. For example, we have parent-child preference to represent preference between an element and its parents. And we have ancestor-descendant preference to represent elements between preference between an element and its descendant. Also, we have the preference path that are generated with by the pref elements in the pref clause. We also divided the Boolean formula into two groups, the group S for mandatory conditions and the group P for the preference conditions. This representation is obtained by passing the request clause by clause. We invite you to check our paper for more information concerning this passing process. So the GTP model is intended to be mapped on the XML2 representation. So we have the query, we pass into its GTP model representation with preference. Here the red ages and nodes are mandatories, and the blue ones are preferences. So during the three-pattern matching process, only substrates that respect all the mandatory conditions and optionally the blue conditions must be returned. But if there exists at least a substrate that satisfies all the red and preference conditions, only those substrates must be returned. Or if not, only the one that best integrate the preference must be returned to the user. So we have implemented three-pattern matching with algorithm preference in Java, and we present it in an extended version of the paper. As early result, we have found that we can extend some existing algorithm by integrating preference with a slight loss of performance, but an improvement in the relevance of the response answers returned to the user. So we can access it through this open repository on GitHub. Also, there are many open source implementation of Xquery. For example, we have Basics that are implemented in Java. Basics is a native XML database that have a lot of functionality. For example, it offers APIs, RESTful APIs, also APIs for integration in languages like Java, PHP, Python, and others. And as future work, we plan to integrate into these open source implementations specification for the language Xquery preference. So the main task here will consist to extend the query processor and evaluation algorithms to integrate all the specifications defined for the Xquery preference language. So thank you for listening. If you have any question, we'll be happy to answer. Thank you.
Thank you, Patrick, for your presentation. If any one of the attendees have a question, you can write on the chat, and then I will repeat loudly for everyone. In the meanwhile, I have a couple of questions, maybe one for the general public and one mostly maybe interesting for our students, maybe it's more trivial answer. First of all, I wanted to ask if you have any consideration, if you did any experiment on the performances of the system.
Yes, we have consideration because we are finding the best thresholds between relevance of answer we returned and performance of evaluations. So as future work, we plan to find the best algorithm for the evaluation of queries with preferences.
And this is interesting. So let us know, maybe, I don't know if it will be next OSS conference or maybe whenever you publish this result, you can tell us.
Yeah.
That's something I think a little reflection maybe useful for our students. It's really about the background, the very background of your work. That of course the speech is the talk is very short, so you cannot emphasize it. But maybe can you emphasize what are the benefits of your solution over a classic relational database implementation? and SQL.
The concept of preferences is also it also actuals on classical database. We have also extension of the SQL language for integration of preferences. So it's also an important problem because if user can explicitly express their preferences, they can obtain more relevant answers to their concerns.
Yeah, this was, I think it was a reflection for our students, because I see there are many online. There is a question from Dimitrios Platis, and the question is, are you considering to publish Pretfig to Stack as OSS, so as an open source system? It is currently unlicensed on GitHub.
Yes, of course, it's an open source because we also have other students that are contributing to these standalone applications. But we think because we already have a big community that have working on BaseX, that is open source implementation of native XML database. So we plan to integrate our specification into these tools and contribute on this community. Yes.
Okay, I hope that this is clear enough for Dimitrios and for everyone else attending. Patrick, thank you. Actually, we started your talk with 58 people. Now there are 59, so there is increasing participation.
Yes.
Thank you for keeping everyone engaged. Thank you, and see you soon. Thanks.
Okay, goodbye.
Bye. Next speech is from Anna Antonova, development of cloud-based microservices to decision support system. So Anna, you are probably already online. I see you.
Yes, I'm online. Hello, everybody.
Please start. You have about 12 minutes, 15 minutes, okay?
Okay, can you see my presentation?
Yes.
Okay. Well, the name of my report is Development of Cloud-Based Microservices to Decision Support System. Creation of simulation system for decision support system is one of the promising area for business processes, supply chains, technological and logistic processes. And using multi-agent modeling becomes a significant direction when developing a simulation system. On the slide, there is a multi-agent model scheme with the following objects: senders, receivers, processes, objects, mechanisms, resources, control actions, agents with knowledge base, and messages. So we have compared three simulation systems: Iris, G2, and AnyLogic. All of these systems are desktop applications, but all of them have some features to interact with internet. For example, Iris allows to create a HTTP request with the results of simulation and upload them to internet. And AnyLogic allows to create Java applets with the models results and models developed and place them to the web. And only G2 is developing in the directions of web-oriented service. But G2 is not widespread because of its costs. So it's topical to develop a web-oriented service to decision support systems. And to achieve this goal, we should choose the model of business processes. So we distinguish some requirements for these models when accounting some features of the business processes. For example, types of resources, different types, and discrete and hierarchical nature of the processes, decision makers models, the conflicts of on the common resources and the mechanisms, and situations diagnosis and decision making. So we have compared three business processes models: multi-agent resource conversion processes model, MRCP model, situations imitation and expert model, Z model by Filipovich, and model effective and passive converters, or APC model by Klibanov and Moskalev. Some words about this model. The key concepts of the MRCP model is a converter or processes. When process start, their their duration is determined on the basis of the parameters of control actions and common limited resources. And the input resources of the processes is consumed and output resources are produced. And the agents can manage the processes using their knowledge base. Well, what about Z model? In the Z model, there are three levels: situation, segmentation, and expert information representation. And the advantage of this model is integration of these approaches and using situation diagnosis. But there is a lack of decision maker models. And the APC model can be represented as a graph, and the nodes of the graph are active and passive converters, and their arcs are the information and resources flow. And this model is based on the scheduling theory and has not decision maker models and diagnosing situations. So as we can see, all requirements are fed by MRCP model. So we choose this model as a basis of our web-oriented simulation service. And the scheme of the architecture of the simulation service with the use of integration interface API is presented on the slide on the bottom figure. And service is managed three entities: simulation process, models, and execution reports. It uses the CRUD notations, and the operators are listed on the slide. And when the simulation service contains these commands, it performs some internal transformations, and depending on the commands, extract or stores the data in the database and start simulation. We simultaneously can start simulation of several models, and the degree of parallelism is not strictly defined and depends on the current settings by users. So we use the open source system Mongo database as a database of our web-oriented simulation service. When we talk about the models in traditional relational database, the many objects of the model we should store in many different tables. And in the Mongo database, all relationships between the objects of the models are stored in the one document, and it's a simple. So on the slide, we can see the task states when the model starts simulate. It's open, scheduled, pending, failed, successful, aborted, and deleted. And also we can see some part of the model descriptions using Mongo database. We have tested our developed BepSimWeb when solving the problem of production flow control in the two rolling mill LPC10 and LPC5. The scheme of this aggregates of this mill is presented on the slide. The problem is to determine such a value of the slab stocks in the input of the LPC10 that ensure their minimum bake waiting times in minutes and minimum volume of the stocks of rows, that's the input of the LPC5. We put JSON objects in the HTTP request body, and part of the model description is presented on the slide. We have conducted some experiments, and the part of results of experiments is presented on the slide. As we can see, the sixth experiment is experiment with the best result. The bake waiting time is minimum and equal to 11 minutes, and we reached the minimum number of rows in the row stocks. So I can make some conclusions. We have analyzed some simulation systems, AnyLogic, ARIS, G2, BPSIM, and have chosen BPSIM as a basis of our web-oriented microservices. And then we choose the multi-agent resource conversion processes model for modeling the business processes, and have developed a prototype web service, BPSIM Web. We have tested this prototype when solving the problem of logistic processes control at the rolling mills. And the further work is related to the modification of the developed BPSIM Web. So I can answer your questions. That's all.
Thank you, Anna. We are, of course, waiting for questions in the chat. In the meanwhile, I have a couple of questions for you. If you can go to slide 8, number 8, it is the second last.
Oh. Okay.
So you show the results of experiments, of your experiment.
Wait a moment.
Yeah, maybe you can share screen. Yeah, slide 8.
Okay.
So it was quick. So I didn't. Do you have any interpretation, any explanation on the fact that why the experiment number 6 is the best one?
Okay. Thank you for your question. We look for the experiments with the best result when analyzing the bake waiting times and search for minimum bake waiting times. In these experiments, the minimum value is 11. And also, we search for minimum of the number of rolls in the roll stock, the output of LPC 5 mills. And this is 503 rolls, and in 6 experiments.
Yeah, we cannot hear you.
Okay, we hear me?
Yes, now yes.
Okay.
It's also a bit small when in your slide, the part of the model description, for me, at least, is not really readable. Maybe okay, it's okay. Maybe you can make it bigger for next presentation. So okay. The second question is, Artyom has a question now. This is exactly the same question that I wanted to ask. So in this case, we have only one question, not two. About your slide 9, the last slide were about conclusion.
Okay.
So you say that further work is related to the modification of the system, and both of us are probably others in the audience wondering what modification you are planning.
We are planning to describe the agents, because now we describe only processes and operations and common limited resources and mechanisms. And now we prepare to describe the agents and the agents rule via production rules in the form of if-then rules.
Mm-hmm.
And that's all.
Okay, thank you. Is there any other question? In the meanwhile, I have to tell you that the participants went from 58 up to 62 during your talk. So you managed to keep the attention and enroll a few more participants. So apparently there is no other question. We can wait maybe a few seconds if there is anyone else that want to ask questions. Otherwise, thank you, Anna. Thank you very much for your participation, for your nice presentation. And we can move to the next talk. I'm not sure who is the speaker who is online for the next talk, because on the Telegram group.
It's me.
It's you.
I'm
Anne,
Nick.
okay.
Yeah.
Okay, you are there. Okay, sorry.
Yeah.
I didn't notice. So thank you for coming. So your name is Anne, right?
No, it's Nick.
No.
And it's one of the co-authors, but I'm the last.
So Nick, okay, Nick, thank you for coming. Sure. And your talk will be the ecosystem of open consequence, a user-led open source foundation. So thank you. You have 62 people now, the inheritance of Anna, that bringing more people. So you have 62 people to entertain now.
Perfect.
And you have about 10 minutes. Thank you.
Thank you. Let's see how many more will join later.
Yes. I will call my friends maybe.
Yeah. All right.
We can see you.
Can you see my screen also?
Loading. Yes, we can see. Yes, we can see.
Perfect.
Please.
All right. So I'm Nick. I'm a postdoc at the University of Nuremberg. And on behalf of my co-authors today, I would like to present our paper. One of my co-authors, Anne, is also in the call. So if you have questions, we could perhaps take them later after the presentation. But let's dig in. So I'll be talking about user-led open source foundations and a specific example, a case study that we did on one such foundation called Open Consequence. So the motivation is that there is more and more open source using companies. Companies are using more open source components in their products, but for some needs of these companies, there is no ready available open source solution that's developed by an open source community. So what are the solutions in this type of a situation? Let's think of an example. Say you're a car manufacturer and you need an infotainment system, software for your infotainment system in the car, but there is no easily available, readily available open source solution. You could develop one on your own inside of your company, but this is very costly and it's not the main thing you're doing. So someone isn't buying a car at BMW, for example, over Mercedes because of the infotainment system. Doesn't make much sense to use your resources there. Another solution is to buy a ready solution from a supplier. Many companies do that, but in this case, you're really dependent on this one supplier, and sometimes the customer data goes through those suppliers, and that's not a very good thing for some customers. So there is a third way, there is a third solution that's also often developed, often used, and that's using open source foundations, where different car manufacturers in this example come together and form some type of a consortium, some type of an association, and fund the common development of an open source solution. For example, it could be Linux-based infotainment system that all of them can then use and modify on their own, but it's much less costly than developing it by every single car manufacturer. And this is what we call user-led open source foundation. And another example, so this was a real example I was telling you about car manufacturers. It's called Genevi, this consortium, and it's in Germany, and it brings together different car manufacturers to create, among other things, the infotainment system for cars. But today we'll be talking about a different example. But before that, let's talk about this user-led open source foundations. You know, most of you know open source foundations, one or two. Eclipse could be one, Apache is another, and there are many more. But what's special about these user-led foundations? Well, it's in the name. They are led by the users. These users are often not software development companies themselves, so they lack this software development expertise. So what they do is they commission the development to some suppliers, but the key here is that these suppliers develop software specifically that meets their needs, the member needs, the members of this foundation. Of course, if it's open source, other non-members can also benefit from it, and that's just fine, especially in like education sector or in hospitals. This is perfect because other hospitals or other universities could use the software developed in a foundation. That's just fine. But if you are part of the foundation, you can influence the software development, and it will be much more aligned with your needs compared to non-members. So that's a reason for you to be part of it. Of course, there are other members of the ecosystem, for example, software vendors who are developing the software, or service providers like consultants. And they are very important parts of the ecosystem. And of course, there are some conflicts involved with all these different type of members. And this is one of the things we looked at in our study, what type of conflicts arise and how, what are the reasons for these economic conflicts. So let's talk about our study subject here, Open Consequence. This is a consortium in Germany that brings together distributors in different energy markets, gas, water, and others. So this energy distributors, they all depend on some software solutions to maintain their grids, to track the failures, and to improve the efficiency of their overall energy supply. but they cannot do it by themselves when it comes to the software tools. This is just too much for individual suppliers. So what the traditional way of doing things was, there was some large monolithic software solution that many of these suppliers would use. They would be dependent on it. They couldn't easily change it, and it's very hard to innovate in such an environment. And the reason for this open consequence was to change this, to create a more modular system where different modules are developed as open source by smaller suppliers that are specifically meeting the needs of the member companies. So the methodology, I already told you about the subject there, and this distribution system operators, the DSOs, are the main members of this consortium. And the goal for us was to investigate the whole ecosystem around these user-led foundations, because this is an emerging topic and there aren't that many foundations like this, and even less research on them. The method we used was qualitative survey by Janssen, which essentially allowed us to go interview different members of this ecosystem and try to understand how the ecosystem works and what some of the conflicts are. So we talked to, among other people, user representatives from several DSOs, several distributor companies, and we talked to some people from suppliers, software suppliers, like a project lead from one service provider, or a consultant in one of the from one of the consulting companies that is involved in the ecosystem. What we did is we interviewed those people, and then we used this qualitative data together with the data that we collected from those companies, like their guidelines and so on, to iteratively analyze and understand what the main concepts are. So once we had these concepts, we continued our iterative process, and then we came up with a theory that explains this specific case. And this is the result. So first we found what triggered the creation of this open consequence, or OK for short, this consortium. Well, as many things are in Germany, a regulation was the trigger. In 2016, there was a new regulation introduced, and the lawmakers wanted this industry to digitalize more. So they created incentives that would help distributor companies become more innovative and digitalize their existing software systems. And this resulted in the creation of the Open Consequence Consortium, where several providers, several distributors came together and tried to do this together, tried to develop this better innovative software together. Well, the main members obviously are these distributors, but they are not the only ones. As I said in the beginning, there are software suppliers that provide different parts of the software infrastructure. For example, some module for grid management, another module for working with the customers, another module for tracking the failures and improving the reliability and the maintenance of the system, and many other modules. And they are very important parts of the ecosystem. How does the ecosystem work? Well, there's a collaboration model. This is, of course, a simplified explanation here, but you can see more details in the paper. The investments are done by all the members, but if there is one specific feature that one member wants to see, he can take the initiative there and start developing. This member would pay 70% of the funding for this specific development, the module development, together with some software suppliers, but the rest, the 30%, will be covered by other members. And this makes sense because all of the members are investing or contributing to the software development that results from the consortium overall, but then everyone has their own priorities and they only develop things that are really important for them and by extension for the other members also. This is economically more beneficial, obviously, than in-house development by a single distributor. This is just like car manufacturers. If one car manufacturer would be developing the infotainment system, it makes more sense to work with others, especially that you're not competing on this specific thing. What are the economic goals of different members? Well, the distributor companies, for them, it's kind of obvious. They want to lower the development costs. They want to lower the software procurement costs. They don't want to be buying this expensive software from one one supplier that they are very dependent on, and they want to lower their costs of grid management because they're using better tools. Software suppliers are another player. For software suppliers, what we found is that they don't really expect to make a lot of money in the short term from this from working with this foundation, but they are thinking about the long-term perspective, and they hope that if they join early on and they provide help with the modules and development, they will be the ones who are maintaining the software in the future years, because it's unlikely that it will change radically once it's all set, and that's their motivation. And then we have consultants. For consultants, they want to provide some additional services, collect data, analyze some data, or sell just consulting projects to different members and try to improve their life. Although there are also conflicts, and that's also an interesting part of our study. We found conflicts between the service providers. It's this smaller software suppliers that work on different modules, because they are competing. Especially they are competing when they are in the same category. For example, if two software suppliers are providing tools for failure management, then they are in direct competition with each other, because the members of the consortium need to choose which one of those service providers will get the contract and will be developing that module. The DSOs, distributor companies, they are natural monopolies, and they are not competing. The reason for this is that in Germany, different regions, say Munich and Nuremberg, they have different distributor networks and different companies providing the energy distribution there. So they are not competing with each other. They are just monopolies in their own regions. But the main conflict arises between the members of the Open Consequence Consortium and the non-members. Well, the non-members want to keep the status quo business plan, so to say, where they are just dependent on one large supplier who is just doing everything, and they are just using it. And the members of the foundation, the OK Foundation, they want to change this the status quo, and what they want to have is a more modular system where software suppliers don't have as much power, and the needs of the specific distributor companies are met in a better way, and they have better software dealing with that. So what problem does this solve? Vendor lock-in would be one. The traditional way is that, as I said, companies depend on this larger supplier, and they are locked in with that supplier, especially that it's not open source, and they can in no way just take over and maintain it on their own or take it to someone else. So they just have to stick with this one supplier. And the goal here for the OK Foundation is to change the situation and to break this lock-in. And they want to see, instead of a monolithic system that's owned by vendors, a more independent, a more vendor-independent platform that has these different modules that are developed as open source software in collaboration with all these distributor companies. Well, yeah, I think that's going to conclude my talk. There is a lot more to say, but not as much time. So I'm happy to answer some questions. Thank you.
Thank you, Nikolai, for your talk. And the good news that you brought participation to 66 people now. So you really increase of 10% almost, something like this. So there are some questions from me, but also from the other participants. Andreas Bauer asking, where can I find the Telegram group?
I don't know if it's a question to me.
Yeah, I don't understand this question. Which one? Yeah, I think it's a discussion about something else. Yeah. Okay. Yeah. No. It's, however, Anne is answering.
I can answer the question too. It's on the website. There is a link to Telegram on the website.
I think this is what he's referring to. So there is a link on the website. Yeah. So my question is that you already, I mean, discussed a little bit, but the focus on the energy sector, of course, is a very strategical and important sector, and you already anticipated. Well, there is some stronger rationale for this.
What do you mean? Why we focused on energy sector?
Yeah. Yes.
Well, among other things, we had good access to this one foundation because we started working with them and following their development from the very beginning, just as they were created. That's one reason. And another reason is that there is already quite a bit of research on the education sector. For example, Quali Foundation is one that is similar in the education sector, and there is quite some research published on that. There is also some research on the automotive sector. Just as I was saying, Genevi is this foundation that works in the with car manufacturers, but not on energy sector. So we wanted to take one field that's not well studied yet, and there was this additional bonus that we have good access to them. So it was very easy for us to go and talk to the exact people that we wanted to talk.
It was very accessible. This is normal. This is normal is one of the reasons why sometimes we make a choice instead of another one. There are other questions in the chat. Laura Sheske, I hope that I pronounced the name correctly. She says, great talk, of course. What is your approach to getting the non-members to join the foundation?
So the main motivation was that all of those members, the distribution companies, they naturally wanted to move away from this traditional way of doing things, from being dependent on this larger vendor. So for them, it was just a natural thing to do, and I don't think they needed to convince anyone to join. The way they were doing it, so they are still doing it on their website. You can see they present the benefits that the members get and how much better the new solutions are, and you can already start using some of them because they are open source, and see if you like it, and then become a member so you can influence the development of the new modules. This was the main way of doing it, but I don't think we found anything that was direct marketing or so that they were doing with the companies. They were just naturally joining because they didn't like the status quo.
In the chat, Anne, your co-author, now she's adding, we are conducting other studies in other industries at present too, and she's posting also the Telegram link. So for anyone interested, probably you can follow that link and see more material. Okay, thank you very much. Now we reached 67 participants, so this was very successful talk. Thank you, Nikolai. Thank you very much.
Yeah, good luck.
So next talk. Next speaker is Alexander Soldatov. The talk is .NET Runtime and Tools for Tizen Operating System. So Alexander, you are online, right? Yeah. Thank you very much. You start with the inheritance of 67 participants, so try to keep them engaged.
Okay. So,
you should share the screen. There is a green bottom on.
Yeah.
Yeah.
So
here it is. Please start. Thanks.
So my name is Alexander Soldatov, and I technical leader of .NET project in Samsung Russia. So Samsung and Microsoft have been developing .NET platform, which called .NET Core, for several years. Usually it's used for server applications and desktop, but we adopted it for consumer electronics like TVs and smartwatches. So I will talk about some challenges and optimizations which we made. So, okay, what is it, Tizen? Tizen is open source Linux-based operating system, and it optimizes it for customer electronics and use it in all Samsung TVs and smartwatches nowadays. And there are more than 100 million devices nowadays with Tizen, and it uses .NET Core platform. So first version was released in 2012, and this operating system is the receiver of MeeGo and Bada. In 2014, we introduced Tizen for Samsung Gear, its smartwatches, and nowadays this operating system also still used in watches. In 2016, we started collaborate with Microsoft to bring .NET to Tizen. What is it, .NET Core? It's also open source platform for .NET. It's worked before on Windows, Linux, and macOS operating systems. But it was not work on Tizen, of course, and doesn't support ARM CPUs. Main languages which use it which supports by .NET Core are C# and F#. Also, it has some restricted support of Visual Basic nowadays. So through the years, there were many approaches for application developers in Tizen. So first approach was native applications. So developers have to use C and C++, but as you understand, it's not very friendly languages, and they have some issues with memory safety, and you have to spend a lot of time when develop applications. So with this SDK was not very popular. And after that was introduced web applications. It's HTML5 and JavaScript. So this technology quite more friendly for developers, but not effective in terms of memory consumption and resource utilization of operating system. .NET mitigate all these disadvantages of both approaches and provides quite rich functionality for developers. So the foundation of .NET in Tizen is .NET Core. It consists of two parts. It's Core CLR. It's is a virtual machine which have JIT compiler, garbage collector, and other subsystems. And CoreFX, it base class library. All these parts interact with the operating system directly and provide basic functionality for developers. On the next level, we have TizenFX API. It's a low-level framework, and Xamarin Forms, which provides UI functionality. So let's talk what we did to bring .NET to Tizen. So we developed ARM backends for JIT compiler and Core CLR, made some optimizations for ARM specific devices, make some tools. Also, Samsung added Tizen support for Xamarin framework, and made some new frameworks for Tizen, which provides C# API for developers. So main vectors for optimizations for consumer electronics is reducing memory consumption and reducing application startup time, which are quite important for embedded devices and some other ARM-based devices. So let's talk briefly about our optimizations. Some parts of code have had absolute addressing, but it's quite good for performance. But when you load such binaries, you have to make relocations for these absolute addresses. So we replaced them to relative addressing and save quite much memory because we can share these binaries between processes. Also, Core CLR have some trampolines for running runtime utilities, or for example, for running JIT compiler for not compiled methods. These trampolines, of course, consume some time and memory. We optimize them for ARM devices, and in some benchmark, we improved performance by 15%. Next optimization is move initialization of runtime as much as possible before application running. For example, if you have cold starts of application, you have to initialize runtime, load system libraries, load some native libraries, and it consumes a lot of time. For example, some application running maybe about 6 seconds. But so we move some parts of this functionality to separate process. We called it candidate process, and when a user just want to launch application, we just load application binaries to this process and execute application. So after that, we move it also some basic common classes from CoreFX and TizenFX to this candidate process. So it also reduced startup time. And finally, we got about more than 15% memory consumption, or reducing memory consumption, since we can share some basic libraries between process, and also we reduce dramatically application startup time. In the end, we faced with issues that developers cannot use Microsoft developer tools for Tizen. For example, there's no WAR debugger and profilers for ARM platform, and they were not open sourced. And since of some patent issues, so we also developed a debugger and profilers and integrated them Visual Studio. Okay, and nowadays C# is a major language for developers who wants to develop application for TVs and smartwatches. It's quite effective in memory consumption and very friendly for developers. This year we bring new version of .NET Core. It's 3.1 for Tizen, for next Tizen. Okay, so that's all. Thank you.
Thank you, Alexander. Thank you very much for your presentation. We brought the participation to 69. So if this is a good metric, apparently it's getting more and more interesting. There is a question from Anna Antonova, and the question is, what disadvantages do have .NET technologies when comparing with the other ones? The disadvantages of the .NET technologies.
So if we compare with C and C++, it's quite, you can write application very fast comparing to C and C++. It has better memory savity and also have better framework. For example, Xamarin is quite powerful framework for application developers. So if we look to C and C++, you have only maybe Qt, but it's not very good compared to Xamarin. Also, for example, JavaScript, it's friendly, but it has some weird type system. You have some issues with writing tests for JavaScript application, and it's not effective by performance. Also, maybe Java have same advantages compared to C#, but there is no open source Java implementation. There is OpenJDK, but it have some restrictions, and it has many restrictions.
There is a question from Artyom that is emphasizing what are the disadvantages, not the strengths. So the disadvantages.
Disadvantages. So.
Yeah, the question was on disadvantages. Yes. So okay, advantage is good. The disadvantages also.
Okay, disadvantages. Yeah, it's not so effective by resource consumption, like comparing to C++. And I think that's all.
So there are way more advantages than disadvantages.
Yeah, and it's maybe some kind of taste. If some people like JavaScript, or maybe some new modern languages like Go or Rust. Some people like C#. Maybe it will be disadvantage for some people.
Just a personal preference.
Yeah.
There is one last question from Andrei Sadovic that, by the way, is also the next speaker. And the question is there open source debugging tools for core.NET or anything on automated testing?
Automating testing is XUnit, I think. And we have NetCore-DBG is open source debugger. You can find it on Samsung GitHub. It's open to public. And it works for the various platforms. You can use on Windows, on Linux, on Tizen, on Mac OS, and it has integration to Visual Studio and VS Code.
Thank you, Alexander. Thank you very much. We need to move to the next talk. Thank you for your presentation. You brought participant to 69, and now Andrei Sadovic has the responsibility to break the barrier of 70. Let's see if he can make it with something engaging. Thank you, Andrei. Please. We cannot hear you. Andrei, we cannot hear you.
Okay, hello everyone.
Yes, yes, we can. Please, yes.
Now,
please.
Okay, let's move on. Okay, thank you for hosting me here, and I would like actually to talk to you about open source and research projects, and in particular, I'll present the results of the project I'm running, which is called Megamart, which actually deals with cyber physical systems. So I have a challenging goal to talk about very huge project in like 10 minutes and have some discussions with you. So actually, I wanted to focus in particular things with you. So first of all, I mean, to discuss a bit of the challenges of the open source for the industry, and especially in cyber physical domain. Then I'd like to overview with you like Megamart project and the challenges towards the open source. So that's something that should be important because it is something that is typical for the industry. And then to discuss like few glances on the practical approaches, how to combine complex tool chain composed on various and heterogeneous open source tools. And finally, I mean, we'll get to some kind of conclusions with few evaluation examples. I'll give you kind of idea about how those approaches were evaluated by the industry and some application example. And so we'll conclude with some kind of discussions. And I believe we will have a room for questions and open discussion. So get prepared for the questions. So and start to type them in the chat. Okay, and so let's discuss. So first of all, why open source in research? What are the challenges? So, and we had very nice discussions by Nikolai and others, what the open source communities can bring to you, and in various domains. He mentioned the grid and water grid, electricity grid. So, and the idea is it lowers barriers for innovation. So new players that want to provide services or new products within those communities can benefit with zero cost, with zero acquisition cost. So and then can create new products. So many tools are currently readily available, really tons. So what comes for innovation? Also to mention that research also most of the time published on the open source license, so you can integrate and you can check what's happening and try this out. And there is actually a community. In many tools, you have community of users, community of developers. Yeah, and so when you want to develop something new, and this is actually was very nice in Nikolai's presentations, which we had like 20 minutes ago, the industry partners can share development costs among themselves and with the community, right? In terms of sustainability, okay, you share the cost for the maintenance of the tools. It's a huge cost. Many companies cannot afford making their own tools, right? And also evolution, it's very costly actually to build tools. And so if you can share that with the community and other people, so that's open source could be useful. And then I've been working with tool providers and those companies that sell the tools. And for us, it's very expensive and very difficult to market the tools and reach those community. And if you provide something for free and that people actually can try and appreciate, then actually push it further to the management. Right. And so as a tool provider, I can sell added value services on top of this huge ecosystem and have a like multiplier effect for my small development, small targeted, nice features. Yeah. Then in terms of challenges, and this we see from the industry a lot, is actually difficult to understand what to choose for my concrete project, for my concrete goals. I need that and that, and only that of that. So do I need all those tools and this myriads and tons of different tools? Which are the tools that are more more of quality, which are being already used in this domain? So yeah, and most of the time we need to integrate several tools to fulfill the whole thing, right? And so we have some open source tools, we have tools from academia. Are they reliable enough? Are they proven? Are they supported? So is there kind of 24/7 support for them? And in many critical industries, we see that this is major concern. So is there anyone behind those tools to get me out of any problem and provide me training? Licensing is also the issue. So with the big companies like in Germany, we face that quite a lot, like with the GPL license. They don't want to hear about that in any context. And that might be kind of reducing. So how to help that, how to support that? Okay. So it's my view on the challenges. I invite you to post a few comments from your side or questions. So let's have a discussion after my talk. Let me talk about MegaMart, its challenges, and our small practical approaches, let's say, how to deal with that. First of all, what is the scope? We deal with cyber physical systems. Cyber physical system means those nice devices like railways, tracks, telecom systems, satellites. Those systems composed of many different devices, software, and also dealing with uncertainty of the environment. So environment dimension is very much important in this business. right? And those systems become more and more software intensive first, and more complex. So they composed of myriads, like hundreds, thousands of different components, and had to deal like with communication, but also with the environment. And what we see from the industry, that more and more industry moves into dealing with our system on, let's say, abstracting the complexity and getting like manageable system models, let's say. And from those models, they can actually derive implementation and use those system models for runtime validation of the whole things. And also on runtime part, so when the system already in operation or when it's kind of in validation, this system components generate tons of different traces when testing or doing operations, and it's very difficult to understand what happens and how to deal with that. And so there should be some kind of methods to analyze and bring this information on the system level, so we can focus on particular aspects and understand what's happening. Okay, and this is like some of the smaller systems when we have like variable mode, mobile network node by one of our partner Techni, where you have software, you have hardware, it should integrate with larger systems. And dealing with that and like designing this system and producing is actually quite a challenge. Right, so we have some more examples from railway, from telecom, from aerospace, and we brought actually a big consortium of companies, 27 companies from various countries, from smaller to bigger one, like Nokia would be big one, smaller would be Raw Technologies. We brought case studies from transportation, smart warehousing, telecom, industrial control, and in this case, in all of that, we need particular things that be present in design environment. And we have actually a bunch of tools, like 28 or 30 tools, but we actually need to integrate them to make the whole design chain. And that might be a challenge. So our project is largely based on the open source, right? And so in this respect, we have like tons of Eclipse based tools, like featured plugins or rich client products. And with that, we also have command line interface tools, software as a service tools, standalone graphical user interfaces, and so on. And so we have a challenge. First of all, which other tools are open source and how we can integrate those which has certain license requirements, and also how we can integrate it with the data that they all have to exchange, right? Then next challenge would be how to deliver that so that end users have compatible versions of all these tools, the right guidelines for each tool, individual tool, but also for the set of all these tools. Right, and so this is a bit of practical approach. We have a specific catalog at Megamart site. I will make you a screenshot. We have also Eclipse Marketplace when we distribute our tools, all bundled with versions that work together. Also, we have specific mechanisms for like Docker container delivery for standalone non-Eclipse tools, and specific dashboards and export import mechanism over specific model format. And this kind of in glance our integration approach, which actually we use massively. Right, with Eclipse IDE, we can actually benefit of specific cheat sheets and specific help that actually integrates. We can use a specific marketplace when we can deliver the tools to the community, all integrated and featuring different functionalities from various tools. Then in our website, we have specific filtering mechanism and helps to select the right one that deals on specific level of like runtime analysis, system modeling, but also in total as the kind of tool set. Right. In terms of, I have to stop at some point. So in terms of conclusions, you remember this variable mode examples, and this actually been designed with specific tool chain featuring open source tools like Chess, starting from system definitions with contracts, with state machines for embedded systems, and with specific analysis of trace logs and getting back and validating system requirements. And using this approach in this tooling, they actually proved plus 50% in early identification of design problems, more predictability and conformance with the requirements, and actually they spent less work time that without this kind of system approach. That actually validates the whole idea. So in conclusions, there is a bundle approach for this very complex area, right? Based on like model-driven engineering, which is actually proven with several, actually 8 case studies in various domains. There are guidelines, example, and there is a support, which is important, through our project community. Some limitations, okay? So there are some integration needed, right? Help needed to getting started. To me, like my personal key takeaways, but that actually it is possible to make cyber physical with open source, right? So then it is validated by industry, and there is a practical integration and delivery guideline that actually can be helpful for those who build open source for the industry. Okay, with that, I would like to conclude and thank my co-authors, Jesus, Dragos, Hugo, Pierluigi, Lara, but the whole Megamart consortium as well, because they provided the tool for that. Okay. So if you have any questions, please.
Thank you, Andrei. First of all, I want to congratulate you for your tie, and you may win the competition for the finest presenter of the of the session, at least. But I don't know, because there are 2 more speeches. So next speakers, they have a few minutes now to maybe redress and compete with you. There is a question from Artyom. Many Innopolis students blame Eclipse as the worst IDE ever. However, I think that they would blame another one that I don't mention, but let's say they blame Eclipse as the worst IDE ever. And nowadays, Eclipse lost about 10% of its share. So the question is, isn't it risky to rely on OSS projects which can lose the support and stay with dead community? How would you mitigate this risk?
Yeah, so that is a very good question. So first of all, again, Eclipse losing it's in Java and some let's say mainstream technologies. However, when it comes to specific techniques, tiny things in terms of embedded systems, cyber physical system, there is no much choice right now. There is no other choice at the moment. I would prefer something more speedy, something more nicer, let's say. But like nowadays, there is not much choice in this area. This is the first one. And I mean, as a user, I would use the best of the best at the moment. And for now, Eclipse would be one of the best. Yes, with that, risks. And you rightly mentioned what are the risks and how to make that avoid those risks. And so we have actually many Eclipse tools that are backed by large industries. Like Modelio, for example, this is a tool that I like and I've worked for 12 years, is backed by the company called Softeam, now Docker Post, and that's been there for 20 years. So risks as such is not that much. And you can also have target commercial services out of it. So it will exist. It will exist for some time. You can also see these tools that with active community. There are some tools with like one person committer, and that's it. And at some point, he may decide that it's done. But some tools like IntoCPS, for example, or AETL, or Papyrus are backed by very large companies, and you can see that from commitments and organization. It's not the same open source, kind of hobbyist open source as you like, and they're quite reliable. I know Airbus, for example, relies a lot on Papyrus, for example. Okay.
Okay, Andrei, I have a few more questions, but I think we are running late because we are about 4 minutes beyond schedule, so we need to interrupt the discussion here. Maybe we can continue it in another occasion. Okay.
Yeah, sure.
Thank you very much. Thank you very much.
Bye
So
bye.
next speaker is Damir. Damir, are you online with using FLOSS for storing, processing, and linking corpus data?
Yes, I'm here.
Okay, you are there. So please share your screen. Okay, we can see your screen. Please start your talk. You have about 12 minutes. Thank you very much.
Hello, dear colleagues. My name is Damir Muhamedcan, and I present the paper named Using FLOSS for Storing, Processing, and Linking Corpus Data that was prepared with my colleagues Olga Nevzorova and Alexander Kirilovich. I will tell you about the Tatar corpus management system, about flows that can be used in corpus management systems, and selection criteria. I will show how we're using flows in corpus management system, and I will sound how we published the corpus on the linguistic linked on Open Data Cloud. We discuss the development of the corpus management system for the Tatar National Corpus Tugan-Tel. You can see its interface on the slide. The development of the Tatar corpus management system was aimed at preservation and the progression of the Tatar language through new information technologies, providing advanced search capabilities for the database of the Tatar language corpus. Researches into the Tatar language heavily depend on the use of the Tatar corpus management system in humanitarian and educational applications, as well as in applications belonging to computational linguistics sphere. The main components of corpus management system are the following: database, search engine, and the user interface. Development of a corpus data management system cannot begin without a clear understanding of which tools will be used to store and process corpus data. Therefore, one of the important factors when choosing and using tools for data storing and processing is, for us, their open source code, which is fundamental to ensure transparency and flexibility of the tool. When choosing tools for processing and storing corpus data, we were faced the task of finding a set of flows to ensure high speed of performing search queries, wide search capabilities, at least direct and reverse search and parts of word forms and lemmas, mixed search, phrase search, and the possibility of further growth of system performance and functionality. The general architecture of the corpus management system is represented on the slide. This model includes three main components: a web interface, a search engine, and a database. Tatar text with morphological markup of each token are loaded into the system database. Interaction between a corpus management system and the users is performed through user queries. The search results contain the set of sentences which include the tokens from user queries. We also made the corpus data set built according to the standards of the Lulol project. To choose flows for storing and processing of corpus data, we formed a list of the most important selection criteria. First is performance. The solution should produce an average of at least 10 search operations per second. Second, functionality. The solution should provide a possibility of direct and reverse search by word forms and lemmas, search by parts of word forms and lemmas, and phrase search. Third, compatibility with other software. Flows for data storage should work with flows for data processing and vice versa. Fourth, completeness of documentation and the presence of a large community. Everyone should be able to continue its development, focusing on the documentation and the accumulated experience of the community. Fifth, development prospects. The solution should develop and maintain modern technologies. So we analyzed information in public sources and choose flows according to second, third, fourth, and fifth criteria. The resulting flows set is presented in slide. To verify compliance with the first criterion, we conducted the series of experiments on writing and searching based on the generated data. So the best results were shown by the MySQL plus Redis suite, which was chosen by us to store data in the corpus management system. To build the system based on the selected components, additional elements must be included. So to bind the PHP interpreter and the Redis data warehouse, we use the PHP Redis extension. In order for the PHP interpreter and the MySQL DBMS to work in tandem, we use the PHP MySQL package, namely the MySQL MD driver, which allows working with DBMS using its own low-level protocol. Thus, the scripts executed by PHP allows operations with data both from the Redis data storage and from the MySQL DBMS, performing operations in the order necessary to solve the tasks assigned to the corpus data management system. PHP scripts are the link between indexes and cache data stored in Redis storage, index tables and text data stored in MySQL DBMS. Let us consider how the processing of a simple direct search query ALMA, Apple in English, is executed. The process execution of such query is shown on slide. First of all, the script that performs this task searches the identifier of the word form ALMA in the Redis database by making a request using the PHP Redis extension. Already at this point, the script may report an error in the query if the identifier of the desired word form is not found in the corpus data. In the second step, the script makes a request to the MySQL database using MySQL MD. In this case, the script needs to get a list of sentences containing the desired word form. This data is stored in the index table of corpus data. In response, the script receives a list of context, sentences, identifiers, according to which, in the third step, the required number of sentences text is requested. The received data is displayed to an user in the form of an HTML document or an JSON structure. The corpus has been published on the linguistic linked Open Data Cloud. The dataset represented in terms of NIF, OntoLex11, LexInfo, OLIA, and the MMOON ontologies. The Reload publishing platform consists in the following open source components shown on the slide. The RDF is stored on the OpenLink Virtuoso Triple Store. The dataset is available via deferrable URIs and the SparkQL endpoint. Deferrable URIs are accessible through the LoadView RDF browser based on the Apache Tomcat web server. The query interface is powered by YaSQLi. So the solutions presented in this article and applied in the developed corpus management system using flows significantly reduced the development time and ensured the transparency of processes, flexibility and possibility of in-depth analysis, as well as opportunities for further development. The corpus data management system is used to work with Tatar texts. The total volume of collection of Tatar text is about 200 million word forms. The average execution time of the direct search query does not exceed 0.05 seconds, and the reverse search is performed by the system within 0.1 second, which exceeded the expected system performance. So in many ways, such performance is provided by flows used for data storage and processing. Also, thanks to flows, search capabilities were expanded in the system. The search using category lists, the complex search using logical expressions, the search for named entities, and other functions were added to the advanced version of the system. Thank you for your attention. You can also ask your questions by email. Our contacts are presented on the slide.
Thank you very much, Damir. There are two questions from Vladimir Ivanov that is probably very much interested in the topic. I think he has background experience in this research. So first question is, does the system support multiple natural languages? Search in several languages.
So we used this system only for Tatar text, but we can use another languages as a source, as corpus data.
And any kind of language or just languages of a specific family? I mean, would apply only to Turkish languages, or it can apply to other languages too?
Other languages too.
Mm-hmm. Okay. So the other question by Vladimir is the OpenLink Virtuoso open source software? Yeah. Is this OSS too?
Yes, I think so.
Yes, yes. Your co-author Alexander is saying yes. Confidently in the chat is saying yes. Yes, it is. Okay. Thank you, Damir. Thank you, Alexander. Thank you, Vladimir, for the discussion. I think probably Vladimir very much interested in getting in touch with you. I suppose they have you share some interesting background, research background. And thank you. Let's move to the last talk of the session. I think is Andrei, the speaker, using of open source technologies for the design and development of a speech processing system based on stemming methods. Andrei, are you there?
Yes, yes, can you hear me?
Yeah, I can hear you very well. Please share your screen and you can start for the last talk of the session. Thank you very much.
Can you see my screen?
Yes, yes.
So thank you very much. Let me introduce our work, our case study about using OSS technologies for design and development of speech processing system based on stemming methods. What about this work is? Data processing technologies nowadays are progressively evolving, and more systems replacing human resources every day. Its tendency occurs in many subject areas, more and more subject areas. Oh, sorry. What do you mean? They need to use some control system whose can maintain in different subject area without human resources. But there is a problem. Many companies needs to its automation very resources, and they are very special. Sorry. Is it good now?
Please, yeah, we can hear you.
Sorry for screen troubles. There are very many special subject areas, and it may be necessary to use many different technologies and many resources to develop the automation system to do that. And our case study works with subject area with call centers. That subject area works with speech technologies. And there are any problems that there are not so many open source technologies used for speech recognition. And we wanted to create the system that may be very flexible and works with different people. So the case study, the proposed solution is the system twin. The proposed system using the dynamic selection of recognition services popular. In our case study, the Yandex SpeechKit and Google, but there can maybe any different system. But this system systems occurs many mistakes with speech recognition, and we need to use some pre-processing and post-processing methods to make these mistakes lower. What about proposed system architecture? There are architecture. I can show you. This architecture using multiple microservices and works with third-party system. As the core system, there are distributed system that occurs many models such as queue manager, billing, and so on. And more interesting is the model for creating scripts and decision support model and message processing and response generation model that works with real human by the talk processing. What about the real-time talking? There are third-party open source libraries such as PBX that can tandem with UniMRCP model and different speech recognition models such as Google Speech API, Yandex Speech Kit, and any different SSA. There are interface for dialog script. The main idea of the script is that the operator that is a specialist in the subject area can customize the dialog scenario for any area as he wants, as he sees it. If we talk about case study with call centers, they may be services, maybe collectors, and so on. At the previous part of the work, we compare the quality of speech recognition of.
Andrei, just one comment. There is, for some reason, there is a bar in the middle of your screen that is not leaving. I don't know if you can see it. Yeah, this bar on the bottom part. In some slides, it's not a problem, but in some slides, it's impossible to read.
Sorry, I didn't see that.
Yeah, thank you. Sorry, I just told you right now because maybe I hope that it was.
Thank you very much.
Going. Thank you.
At the previous part of the work, we compare the third-party systems that used for speech recognition as example of the Yandex and Google speech recognition systems, and achieve the results that Yandex better works with short and emotional phrases, but human, and Google works better for sermons and long sentences. We decide that there needs a post-processing and decision-making model that can work with recognized text and somehow process it for more readable for algorithm, for robots that may be created for the by the script I previous present you. Here is the recognition algorithm at the itself, and let's watch more deeply. For the post-processing, may be reasonable to use the stemming algorithm. There are algorithms that can work with text data, voice data presented in text, and process it by a language construct to help the automated system understand what any sentence means. There are many algorithms and many systems that can work with that. So we decided to use the tandem of the many methods and improve them. The most quality methods is the stochastic method and lemmatization, but they are high enough to implementation. So we decided to add the post-processing system, not but barely using the libraries that can post-processing by the stemming method, and use our own dictionaries that can work as a stochastic tree with weights. It's a keyword system and stop list system. I think they are easy to understand what I mean, but let's go more deeply. As the first part of the post-processing, the processed recognized by the third-party system text go to the lemmatization model. As a lemmatization model, use the third-party open source library called PHP Morphy. Then the lemmatized text go to the additional post-processing model that works with keyword, stop-word matching system, and ranking model. By the running call real scripts in the speech with human and robot, system can teach itself more and more. So it's like a simple machine learning system. By the ranking improves the more sense that that branch can be used in next time. Then the recognized text go to the decision making and response generation model. This model compares the recognition text with the script scenario created by expert, as I previously said, and then provide it back to the robot to can call by PBX and UniMRCP to the third-party system to speak it, to synthesize the voice data by the text data. As I already said, they present a post-processing algorithm using the stochastic weight tree. The stop-word system use a similar algorithm, but they use special symbols, pluses or minuses, to mark that any words in the sentence definitely should be recognized or not. And a few words about the used technologies for lemmatization and stemmings. There are libraries called PHP-Morphy, as I already said. This open source solution works with lemmatization for make the first form of any words and check their lexical meaning. And another very important library called Verifani Petrovich. It works with words endings. As a conclusion, I can say that open source solution provide ability to integrate various implementation or existing methods, and as every one of us know, may improved for any area. So use that, we can create the flexible systems that can be used in many subject area and widely using. That's all. Thank you very much.
Thank you, Andrei. We are running late. There are no questions, but just one quick observation. If you can quickly answer to this one. What was the rationale behind the choice, architectural choice of microservices? It's something related to scalability or just
yes. It related to scalability. I didn't talk deeply with that, but the reason is that this system works in real time at the phone call, and they are a very high load system, and it's stored in the many data centers, and they are necessary to use the microservices for the scalability. It won't be work in different cases.
Thank you, Andrei, for this clarification. I think it's useful, especially also for our students.